Hello everyone, welcome to Physics CQ-METANS. This is the second video lecture on vector analysis. These are the topics I will be discussing in this video. I will be discussing multiplication of vectors, in which I will discuss the scalar, which is also called as the dot or the inner product, and the vector product, which is also called as cross product. So first, scalar product. Now this is a product. So the product of what? We have two vectors. We are discussing about vectors. So I have vector A and B. So there is some operation between them. So let's say this star is some operation between A and B. So this result, okay, the product of A and B, some product of A and B will lead to an answer which is a scalar. So such a product is called as the scalar product or the dot product. By the dot name comes, we will see. It is also called, if we are dealing with quantum mechanics, so this is called as the inner product. So if we have two vectors A and B, scalar product of these vectors gives a scalar. So as mentioned over here, and it is written as A, this dot with B, and that is why the name comes dot product. Now, the scalar product by definition is equal to magnitude of vector A. So this bold-faced is vector. So this magnitude of vector A times the magnitude of vector B times the cosine of angle between them. So if this is my vector A and this is my vector B, so the angle between these two is theta, say. So it is given as magnitude of vector A, magnitude of vector B times cosine of theta. So mathematically we have written A dot B is equal to magnitude of A, magnitude of B into cosine angle between them. Now this property we will use, that scalar product are commutative. So this property we will use. So commutative means what? I do A dot B or B dot A, it is same. So this property we will use, this result we will use when we see the unit vectors. Now the projection of vector. So projection we have discussed in the last video, but still we will see what it actually is. So projection of vector means how much one vector lies along the direction of another vector. So if this is my vector A and this is my vector B. So if you remember, we said that if we put a torch over here, so this B is the shadow on A. So it is how much that vector B has along the direction of A. That is what this projection means. So we have this figure. So from figure means this figure. So we can see this is the vector B, this is the vector A, and the angle between them is theta. So how much is this vector B on this vector A? So if we complete this triangle, so this is the projection. So if we put a torch, we will see that this B will have a component like this only. This much will be the part of B along this A. So if we see this triangle, so this is theta. So we can write cosine of theta is equal to, say, this is bx. This component along the A is bx divided by, so adjacent upon hypotenuse, that is b. So we get bx is equal to b magnitude cosine of theta. So this is what we write, b cos theta. So we can see that b cos theta is the projection of B on A. So how much is this B along this vector A? So even if this is my vector B and this is my vector A, so this will be A cosine of theta, which means the projection of A on B. So now A is getting projected on B. So we can use this. So now if you remember, we had this A dot B is equal to magnitude of A magnitude of B into cosine of theta. But what is this B cos theta? B cos theta we have just defined, it is projection of B on A. So can we write this magnitude of A, B cos theta as projection of B on A? So this is nothing but this B cos theta. So A dot B we can write it as magnitude of A times projection of B on A. Or else alternatively what we can write is A dot B into this A cos theta is projection of A on B. So it will be magnitude of B times projection of A on B. So now if we write the components, so this A, we know that vector A is written as Ax I cap plus Ay j cap plus Az k cap. There is a dot over here, so I put a dot over here, and B is written as Bx I cap plus By j cap plus Bz k cap. Now we have to open this bracket. So this multiplies with this. So this Ax and Bx are just numbers. So this Ax, Bx, now this is the direction. So I, there is a dot in between and there is I. So this is how we have written over here, I dot I. Now similarly the first term and the second term. So Ax, By, I, there is a dot in between and J. So I dot J. This is how the terms are coming. So Ax, Bz, I, there is a dot in between and K. So this is how the third terms come. So similarly now Ay, so if we perform we will get every terms. Now we have to note that unit vectors are orthogonal, that is the angle between them is 90. So just to give you an flavor, this is the I vector, I cap, which is along the x-axis. This is j cap, and the third one is this k cap. So we have this unit vectors I, j and k. Now we know that this I, j and k are along the x, y and z coordinates respectively. So we know that I and j, sorry, the coordinate x and y, they are perpendicular to each other. The angle between x and y coordinate is 90. So if I and j are the this unit vectors along x and y, so the angle between them is 90. Similarly, the angle between I and k should be 90. So that is what this orthogonal means. Now we will use this. So over here we have some terms. What this means? I dot I. What to do about this I dot I dot j, I dot k, etc. etc. So we come over here. I dot I. Now I has unit vector 1 whose magnitude is 1. So I, the magnitude is 1. This dot, this I has a magnitude 1. Now I and I. So both of them are in the same direction. So the angle between them is 0. So it is cos, the angle between them is 0. So these are parallel to each other. So 1 dot 1 into cos theta. But now cos 0 is 1. So we get this as 1. So I dot I is 1. Similarly, with the same thing, if I do j dot j and k dot k will be equal to 1. So all these terms which has I dot I, j dot j and k dot k will survive. Remaining terms we have to see what will happen to the remaining terms. So for the remaining terms, let us take I dot j for example. The magnitude of I is 1, magnitude of j is 1. Now I and j are perpendicular to each other. So the angle between them is 90. So cos 90 is 0. So I dot j becomes 0. So I dot j, j dot I, this I dot k. Similarly, we can write I dot k and j dot k as equal to 0. Now we studied that A dot B is equal to B dot A. That scalar product is commutative. So if I dotted with J is equal to 0, then J dot I will be equal to 0. So similarly, I dot K is 0, then I then K dot I and this K dot J will be 0. So if you notice, these are the cross terms. So I dot J, I dot K. So these are cross terms. So all this becomes 0. So in this equation, this terms I dot J is 0, so this becomes 0. Then this I dot K, this term becomes 0, this term becomes 0. So all these terms which have this cross terms, they dies off. So what we are left with, ax bx I dot I is 1, ay sorry ay by, so I j dot j is again 1, and az bz k dot k, and k dot k is 1. So what we can write is then a dot b is equal to, so what survive is ax bx, ay by, and az bz. So from here all the terms get equal to 0, only the term which has I dot I, j dot j, k dot k survives. So we get this equation. So now there are couple of cases we will see. If a and b are perpendicular to each other, so this should be over here. So a dot b, we can write it as magnitude of a, magnitude of b, cosine of angle between them. As they are perpendicular, theta is equal to 90. So this becomes, so cos 90 is 0. So we get ax bx plus ay by plus az. This is bz. Sorry, this is equal to 0. So this is what we obtain from this case. Now the second case is important. We will see this. So if A and B are parallel, so the angle theta between them is 0 degree. So I can write, so this we can write it as ax bx plus ay by plus az bz is equal to 1, because the angle between them is 0, so this becomes cos 0, and cos 0 is 1. So actually we should write it as magnitude of A, magnitude of B. So but fine. So this is the part. So if this is the case, so actually here it should be magnitude of A and magnitude of B, but I'm just calling it 1 for simplicity. So this AX, I can write it as equal to some scalar multiple of BX. Similarly, this AY, we can write it as some scalar multiple of BY, and AZ, we can write it as some scalar multiple of BZ. So from here we get AX divided by BX is equal to K, AY divided by BY is equal to K, and AZ divided by BZ, that is equal to K. Now if we notice, all these terms are equal to a scalar constant, that is K. So I can write AX by BX is equal to AY BY is equal to AZ BZ. This result is very important. We will use this result when we will study the lines and planes. Specifically in lines, this is very important equation. We will parameterize the equation of line and all. At that time this will play important role. Even finding the slope, we will see how it is. Now where do we use the scalar product? So a very simple, the known physical quantity is work done. Work done is force into displacement. delta s or ds, whatever you want to write. So let us write it as delta s for now. Now this force is in vector, displacement is also in vector. So the dot product of this gives a physical quantity, that is work done. And work done, we know it is a scalar. It is just a number, 100 joules, 50 joules, 500 joules, etc. So now we, from the results also, we, if we see, we know that when force and displacement are parallel to each other in the same direction, work done is maximum. When force and displacement are perpendicularly to each other, the work done is zero. So this is how we can relate. Now next is the vector or the cross product. So it is also called as the cross product. Now this is a product, but it is giving me a vector. So if I have two vectors A and B, so if I have two vectors A and I do some operation B, I will get a result, and this result leads to a vector. This is a vector quantity. So the vector or the cross product of A and B can be written as A cross B. So this operation which we are doing is cross. So don't get confused this as multiplication sign. This is the cross. We read it as cross. So by definition, vector or the cross product results in a vector, as we have defined over here. If we have two vectors and if I do some operation, that is the crossing of this A and B, taking the cross product of A and B, we get it as a vector. Now the magnitude of A cross B, so remember this is the magnitude of A cross B, is written as magnitude of A, magnitude of B into sine angle of theta, into sine angle of theta between them. So where theta is the positive angle between A and B. Positive angle means if I have this vector A and if I have this vector B, so this theta is the positive angle from A to B. So this is important, how we write A cross B. So I have to, the angle should run from A to B. Then the direction. Now if this is a vector, if A cross B is giving me a vector, so that vector should have a direction. So how to find out the direction of that vector? So it says that the direction of A cross B is perpendicular to the plane of A and B. So if this is my A and B, so if I draw this plane like this, for instance, so the perpendicular to this plane will be the direction of this A cross B. So you can take the book example. So if you take book, so this is the one edge of the book, this is the another edge of the book, right? So if you just place the pen on the surface of paper, that book, so you will find that pen is pointing in the direction of this A cross B. So this, the direction also can be given by the right-handed screw rule. Right-handed screw rule rotated from A to B. So how to use this right-handed screw rule? So there are two ways. So we can take our palm, right hand, and place the fingers in the direction of this A. Like we will stretch the fingers of the right hand, the palm of the right hand in the direction of A, and curl the fingers. Curl means rotate the fingers in the direction towards B. So this fingers, we will rotate it in this direction. So if we have placed the palm like this, we will rotate it to the direction B. Now the thumb will be remaining, that thumb will point a direction, whether it is outward, inward, up, down, whatever. So that thumb shows the direction of this A cross B. Other way around, if we take the screw, now if I want to put a nail inside the wall, what I have to do is I have to rotate it in the clockwise direction so that it will go inside. So that is how also we can use the screw rule. If there is any doubt, you can just post in comments. I will explain this right-handed screw rule more neatly. Next is vector product is non-commutative. This is very important. We will use this many a times. A cross B is not equal to B cross A. Rather, what we can write is if the ordering is changed, A cross B, if I want to change the order, I have to pull a negative sign. So A cross B can be written as minus B cross A. This minus sign is crucial. So that we will use over here. Now we can write A cross B. So A, we know we can write it as AX I cap plus AY j cap plus AZ k cap. There is a cross in between. So the cross comes over here. And this vector B, we can write it in this way. Bx I cap plus By j cap plus Bz k cap. Now, I will just show a few terms. So this AX and Bx. AX I am multiplying to this bracket. So I get AX, Bx, I, there is a cross in between and I. So AX, Bx, I cross I. Next is this AX multiplies with this. So AX, By, this I, there is a cross in between and J. So AX, By and I cross J. Similarly, this third term will be AX, Bz, there is I, there is a cross in between and K. So I get the third term. So similarly, if you open up this bracket, you will get the all these terms, all the remaining terms. So now what this I cross J, I cross K physically means, let us see that. Is it going to give us direction or what? Let us see. So I cross I magnitude, we are talking about magnitude because magnitude of A cross B is equal to magnitude of A, B sine theta. So magnitude of I is 1, that should be a cross. Magnitude of I is 1. Angle between them is 0 because I and I. So these both are parallel. The angle between them is 0. So sine 0 is 0. So all the terms, now it doesn't matter magnitude and direction. If we know, if you remember, we studied zero vector. So zero vector means the magnitude is 0. So it does not have direction. So all these terms which contains I cross I, J cross J and K cross K, this dies off. This goes to 0. So these three terms we get rid of. Similarly, as I mentioned, J cross J and K cross K, as they are in same direction, they becomes equal to 0. Now let us see the cross terms. I cross K. Now I cross J, sorry. So the magnitude of I is 1, the magnitude of J is 1, sine of angle between them is 90. The angle between I and J is 90 because they are orthogonal. So it becomes 1 because sine 90 is 1. So the magnitude of I cross J is 1. So we are talking about magnitude. Direction we have to specify. Similarly, if I do J cross K and K cross I, the magnitude is 1. Fine. Now let us come to this J direction. So we have talked about magnitude. Let us see about the direction. So I cross J. So I cap cross J cap. Now place the palm in the direction of I. So I means XYZ coordinate system we are talking of. So place the palm in the direction of I. Now curl it to the direction of J. So you will rotate your fingers in this direction. Sorry, this is J. So check your thumb will be pointing in the K direction. So I cross J will become K. So where this I cross j is, so this becomes k. Similarly, if you do j cross k, so if you have j and if you go to k, you will get, so just place the fingers in this j direction, curl it, rotate it to this direction of k, you will find out your thumb is pointing in the I cap direction. So wherever this j cross k is, here we will put it as I cap. Now k cross I, so k cross I will become j. Similarly, just try to find it out. Now, if I do, we know that A, we have studied this, A cross B is equal to minus D cross A. We know this. So, if I reverse the ordering, so it is I cross J, if I do J cross I, so it will pull a negative sign. So that is why we have wrote it as J cross I is equal to minus K. And similarly, k cross j will be minus I, and k cross I cross k will be minus j. So if we substitute over here, I cross k is minus j, then j cross I, this j cross I is minus k. So this we have already substituted. So this k cross j is minus I. So this is all we obtain. Now there is a cyclicity rule, hence this we call it as trick, but actually it is not trick. We can use the right hand rule over here in this diagram and find it out. So I, j and k, we write it in this way, and we draw this cycle. So this is the arrow, the flow is important, how it flows. So I, if the arrow, see the where the arrow goes, so I cross j will give me k, j cross k will give me I, k cross I will give me j. If I reverse the order, so if I move from I to k, so I'm going in the opposite direction. So opposite direction means I have to pull a negative sign, so it gives me minus j. So if j cross I, if I do, I get it as minus k, so on and so forth. Next, now the case, if A and B are parallel or anti-parallel, then A cross B will be 0. That we know. I cross J terms will come up. Sorry, I cross I, J cross J, K cross K terms will be there, and that is why this vector A cross B will be 0 if they both are parallel. Now from previous equation, just I have substituted this. So I cross j has become k. So ax by k cap, ax bz minus j cap, ay bx minus k cap. That is what is written over here. Now I take the like terms. So what we do is, so this k cap is over here, k cap is over here. So I do ax by, there is a minus sign over here, so minus ay bx. So I get this first term in the k direction. Now comes this j. Now minus sign I am taking common. The reason I will tell you. So ax bz, this term, and another j term is this. So if I am taking minus sign common, so this becomes minus. So ax bz minus az bx in the j direction, and remaining is the I. So here we have this I term. So ay bz, there is a minus sign over here. So minus az by into I. This is how we can write. Now this cross b, there is a very nice way to write this a cross b. So this is vector a cross b is equal to determinant of I, j, k, AX, sorry, AY, AZ, BX, BY, BZ. So this determinant is known as I. Now what we do is we hide this row and column and multiply this one. So AY into BZ, this is AY into BZ minus, so after multiplying this two we have to put the minus and multiply this two, so it is AZ BY. Now when we solve the determinants, this middle term, so the second term, we have to put it as minus. The ordering goes in that way. So this is plus, this is minus, this is plus. If we are solving the fourth one, so it is minus plus minus plus, it goes in that way. So it is J. So we will hide this row and this column. This multiplied with this, that is AX BZ minus, there is a space I am writing over here. So this AZ BX. And the third term is plus K cap. So for K cap, we will hide this row of K and the column. So we will multiply this two. So it becomes EX BY minus these two terms, that is AY BX. So this is what we get. And if you notice, if you check this, this is the same result which we obtained over here. So taking determinants is good for solving. You can solve by using this also. You can solve it by using this equation. But the more nice and more good way is by solving this determinant. So the physical, what is the physical significance? So we have studied about the torque. Torque is equal to R cross F. We know that torque is a turning moment. So turning. So now for instance, we have seen in physics, we know that if this is door, so these are the hinges of the door, and say this is the handle. Now the handle is placed over there. So if you apply the force at the handle, you will find the door will close very neatly, very nicely. But if you, and the force required is less. Why? This R is greater. So R is the point at which the force is applied. So it is the distance from the point of this point of contact to the point where the force is applied. So, but if we apply the force over here, just right to the hinges, you will find you have to apply more force. Means you have to generate more torque so as to push that door. So this torque gives the turning effect. Now, if you notice, this curl represents something with the curling. This cross product, sorry, this represents with the curling of vector. So we will see this. So this has a very good examples in this magnetostatics, electrostatics, electrodynamics. We will see. So that's it for this video. I hope you find this content useful. Thank you all for joining me. See you all in the next video where we will discuss lines and planes. So thank you a lot.